Alright, so previously we've seen three different proofs of the Pythagorean theorem, and the Pythagorean theorem just says that the leg squared plus the leg squared equals the hypotenuse squared. And what we're going to do today is we're going to look at the converse of the Pythagorean theorem. So when you think converse, okay, you should think going backwards, opposite. So starting with the hypotenuse and working to find the other parts, okay? So we're going to prove the Pythagorean theorem using the converse, okay? So like in science, you always start with the hypothesis, right? And then you draw a conclusion. The converse is getting a conclusion to find a hypothesis, all right? So we're just working backwards. So we look at these two triangles here, okay? We have A, B, and C here, and A prime, B prime, and C prime here. The sides are A, B, and C on the left, and A and B on the right. And on the right, we have a right angle. So we can see that the one on the right is a right triangle, but we don't know that for sure here, so we would have to use rigid motions to prove that triangle ABC is a right triangle. All right? So we can't prove that this is a right triangle without moving it. Would we be able to use rigid motions to get A prime, B prime, C prime on top of ABC? Yeah, we could translate it over and prove that, right? Okay. So we're going to jump into the converse, and you've seen it a little bit in the mixed module, but we're going to go through and in lesson 15, so we're going to go through it some more here in exercises 1 through 7. So is the triangle with the lengths of 3 miles and 8 miles and a hypotenuse length of the square root of 73 miles a right triangle? I would suggest drawing a picture, and it doesn't have to be drawn to scale. Just draw a right triangle, 3 miles, 8 miles, square root of 73 miles. When you draw a picture, it's going to be a lot easier for you to see this and visualize it than just looking at it, the numbers. Okay, across from the right angle is the hypotenuse, which is C. The other two are A and B. And it doesn't matter which one is A or which one is B as long as you use those two sides as A and B. So I'm going to do this. A squared plus B squared equals C squared. And this says show your work. And everything I write right here is my work. And if you don't have your work and you miss it, you're not going to get any partial credit. Do we understand that? You got to show your work. Okay, so then I'm just going to plug in for A3 and bring down the square. I'm going to plug in for B8 and bring down the square. And I'm going to plug in for C, the square root of 73, and I'm going to bring down the square. Okay, so 3 squared means 3 times 3, which is 9. 8 squared means 8 times 8, which is 64. When we square this, the square root and the square cancel each other out. So all we're left with on the right side of the equation is 73. If we add 9 and 64, we get 73. Does that equal 73? Yes. So the lengths do form a right triangle because they satisfy the Pythagorean theorem. Okay? Number 2. what is the length of the unknown side of the right triangle shown below? Okay, so it's a right triangle. The unknown side is the side across from the hypotenuse, which is C. Okay, so same thing, A and B across is C. So A squared plus B squared equals C squared. So 4 squared, I'm getting this from here, plus B squared is 1, B is 1, so 1 squared equals C squared. Okay? So I'm going to take 4 squared, which is 16, 1 squared, which is 1, and then I'm going to add them together. 16 plus 1 is 17 equals C squared. So to solve for this, okay, it asks to show your work and answer, and it says to provide an exact answer and an approximate answer. So I'm going to show you what that means. We square root both sides. So the exact answer would be C equals the square root of 17. Exact. Okay. If we were to put that into a calculator and do 17 square root, that is an approximate answer. And it says to go to the tenths place, and that means one number after the decimal. So it's 4.12. The 2 is less than 5, so we will say it's about, and it's a squiggly equal sign, 4.1, and that's the approximate. And it says to answer in a complete sentence. So, the length of the hypotenuse is exactly the square root of 17 inches, and approximately 4.1 inches. Okay, 3 is just like the one we did. So try working ahead of me. Okay. Across from the right angle is C. So the two sides that make the right angle are the legs, which would be A and B. So A squared plus B squared equals C squared. 2 squared plus 6 squared equals C squared. 2 squared is 4. 6 squared is 36 equals C squared. And notice that the C squared stays over there. I don't move it. It stays lined up the whole time. 4 plus 36 is 40. To solve for C, you have to square root both sides. So C equals the square root of 40 exactly. Okay. And 6.3 approximately. So 6.3 is approximately C. Then you would write your answer in a complete sentence. The length of the hypotenuse is exactly the square root of 17 millimeters. Do not forget your units. And approximately 6.3 millimeters. Yeah, I don't know what I did. Sorry. 40. I didn't mean to confuse you. I looked at that. I looked at number 2. Okay. So, number 4 is the triangle with the leg lengths of 9 inches and 9 inches and a hypotenuse of the square root of 17 inches, a right triangle. Show your work and answer in a complete sentence. Okay, so this is C. These are A and B. Okay, the hypotenuse is always C. The other two don't matter, but the hypotenuse is always C. So A squared plus B squared equals C squared. So 9 squared plus 9 squared equals a square root of 175 squared. Okay, all I did was take the Pythagorean theorem and plug in the 3 numbers. So 9 squared is 81. 9 squared is 81. The square root of 175 squared, the square and the square root cancel each other out. So we're left with 175. If we add the left, we get 162. Does that equal 175? No. So we would say this is not a right triangle. Because the lengths do not satisfy the Pythagorean theorem. Okay, I'm going to work quickly through 5 and 6 so we can get to 7 before it's time to go. So if I don't pause for you to write, pause the video yourself and write. Okay? So,
Pause the video.
So we have a triangle with leg lengths of the square root of 72, or square root of 28, good grief, and 6 and 8. So a squared plus b squared equals c squared, square root of 28 squared plus 6 squared equals 8 squared. 28 plus 36, does that equal 64?
Yeah, cool.
Shh. Shh. Okay, when we square a square root, they cancel each other out, and we're only left with the 28. 6 squared is 36, 8 squared is 64. We add the 28. They are equal, so this is a right triangle because the lengths satisfy the Pythagorean theorem. Six. What is the length of the unknown side of the right angle shown below, a right triangle shown below? So across from the right angle is C. So the other two sides would be A and B. Okay? So A squared plus B squared equals C squared. 3 squared plus The square root of 27 squared equals c squared. So 9 plus, these cancel, 27 equals c squared. So 36 equals c squared. If we square root both sides, c equals 6 feet. The length of the hypotenuse is 6 feet. Complete sentences, people. Six. Okay. Or sorry, 7. The triangle shown below is an isosceles right triangle. Isosceles triangles mean that two of the sides are the same length. So that would mean this is x and this is x. They're the same length. Determine the length of the legs of the triangle. Show your work and answer in a complete sentence. So across from there is C. These would be A and B. So a squared plus b squared equals c squared. I'm going to plug in x for a and bring down the square. I'm going to plug in x for b and bring down the square. And I'm going to plug in the square root of 18 for c and bring down the square. Now, these are like terms. So we have one x squared and another x squared. So total we have 2x squared equals, this is 1 and this is 1, so we add them together. These cancel, so we're left with 18 over here. We want to get x squared by itself, so we divide both sides by 2. X squared equals 9. We square root both sides. X equals 3 centimeters. So the length of the legs, the length of each leg would be 3 centimeters.